Okay, so I actually made the practice test and the test at the same time. I had the program open on two screens, and then I put a problem on the practice test, and then I put a problem just like it on the actual test. So the test and the practice test match like the exact type of problems, but on the test there will actually be some of these just repeated exactly as is, and then there'll be some questions just like it. Something I made sure to do as I was making this is the harder of the problems. So on the test, there's nothing more hard than this. So don't expect anything harder. Like I made sure if I was giving you a challenging problem, it was on here or there was something very similar to it on here, so there was no surprises. The test will actually only be 20 questions to give you enough time in class to solve everything. This here is 30, so it's actually more comprehensive than the test. We're going to go through every problem here. If you want to squeeze the work on this paper, you can. If you want to work on another sheet of paper just to give yourself more room to solve stuff, that is cool too. If you want to like solve stuff on the back, it's totally up to you. I will be giving you credit for completing this, for showing all the work on every single problem. If I get time today, I'll go around and check and make sure that you showed all the work, and I'll give you credit for it today. If we run out of time like I did in my last class, I'll just have you turn it in tomorrow, and then I'll give you credit for it tomorrow. Any questions? On this, I will try to squeeze in the work as much as I can right on here. There's a couple questions where it's not possible, there's not enough room, and for that, I will just use a sticky note, and it'll kind of run down. I think that's Peyton. Okay, make sure your name's on it, of course. It's third period, so put that down. And then I'm just going to kind of quickly go through the problems. Starting with number 1, and I'm going to zoom in here too so you can see better. Also, I will be putting this recording up on our YouTube channel, and this is also printable off Schoology, so the best way to study tonight, honestly, would be to print this off again and work through the problems on your own. Either with the video or on your own and just like checking your work. That would be the best way to study. So first one, evaluate each expression just using order of operations, PEMDAS. First one is rather simple. We're going to do the multiplication and division first in the order of the problem, so we get -12. -12 divided by 2 would be -6. Bring everything down. Be -3. That's our answer. And again, I am working through these rather quickly. If you see me make a little error, just let me know so I can fix it. The next one, order of operations as well. Of course, this is an example of a harder problem. There's not going to be anything more hard than this. So here we have the brackets and the parentheses. We solve within these parentheses first, starting with the exponents. So we get 36. Bring everything down. 2 times 2 would be 4. (36 divided by 3 is 12. 12 times 4 is 48. (20 minus 96 would be -76, and 12 minus that. When you subtract a negative, you add the opposite, so it becomes 12 plus 76, which would be 88. Yes?
How did you get 48?
So I did 36 divided by 3, which was 12, and then 12 times 4 was 48. Yes?
Isn't multiplication supposed to be first?
Multiplication and division are one step, and it's in order of the problem.
So
Mind blown.
PEMDAS, it's multiplication.
Yeah, it's in the order. It's just how they write it.
Same with addition and subtraction.
It's you just take whatever comes first with multiplication, division, or no, yeah, multiplication, division, and addition, subtraction, whatever comes first.
Did you get the same answer doing it your way? No.
Oh, I did it like multiplication first and then.
Sometimes it'll come out to the same answer, but it is in the order of the problem. Yes?
How How did you get 12 plus 76?
So it was 12 minus negative 76, and then with the subtraction and the negative, you add the opposite.
Oh,
Okay. Next, oh,
So you wouldn't distribute that negative?
this here.
The negative, it's like 12 minus, and then the bracket's 20 minus 96.
You could. You'd get the same answer.
Okay, 'cause that's what I did.
Yeah, you could. Then evaluate each expression. Oh, there's something. See how it's cut off here? It says and g equals 1/3. Okay, so this is essentially the same thing as up here. The only difference is they give you variables, and then you have to put in these values for the variables. So that's what I'm going to do here. A is 3/4. B is -8. Look at this. Following order of operations, parentheses. A lot of people see this and they think, oh, I have to do this first, but there's nothing to solve within those parentheses. That's just multiplication there. So we're going to start with the exponent. 3 times 3 is 9. As I'm bringing everything down, the next step is going to be multiplication. So 3/4 times -8. You could do that in the calculator. You could do 3 divided by 4 to get 0.75, and then multiply that by -8. That would work. The other way to do it is just multiply your fractions. So over here, 3/4 times -8 over 1 equal -24 over 4, which is -6. So I would get -6 over -2. -6 over -2 would be +3 plus 9, and I get 12 as our answer. Number 4, same. So -6 divided by -2 would give you +3.
Oh, -2.
Next one, plugging in values. A is 3/4. C, -2 squared. Okay, starting out, I'm going to take care of the exponents. So bringing everything down. -2 times oh wait, this is I wrote down 2, but it's actually 3. -2 cubed. -2 times -2 times -2 would be -8. Minus -8 times -8 would be +64 here. The next step, I'm going to be multiplying, and I see a really easy multiplication problem right here. 3 times 1/3 is just going to be 1, so I can get rid of that fraction, which makes me happy. Whoa. Next step is to do your multiplication. 3/4 times -8. We just did that problem up here, and it is -6. 64 times 1 is 64. And we get -70 as our answer. Number 5, evaluate this expression, and then it gives you the value of the variables. So plugging that in, 12 times 3. Okay, first step is going to be multiplication. 12 times 3 would be 36. Minus 24 over 6. 12 over 6, which equals 2. Okay, the next set of problems It says name the set of numbers to which each number belongs. And it's either real, rational, irrationals, integers, wholes, or naturals. This is the chart that we used to consider these. Let me zoom out. It was right here. Real numbers are everything in this chart. It includes rationals and irrationals. Rational is a number that can be represented as a fraction. Irrational is those weird numbers like square root of 3 or pi, where when you put it in the calculator, there's no pattern or rhyme or reason to it. It looks like this, square root of 3, and it looks a number like this. There's no pattern. You can't represent that as a fraction. Same with pi. When you plug it in, just no pattern there whatsoever. So that would be irrational. Integers are negative or positive numbers, and they do include 0. Whole numbers, that is. So there's no decimals for integers. And then whole numbers is whole numbers, but it does include 0, no negatives. And then naturals is all your whole numbers, no zeros, no negatives. Okay, now looking at that, we can apply that here. So you just kind of go down the list. This is a real number because it fits in the chart. It is a rational because it can be represented as a fraction. It is not irrational. It is an integer, positive or negative number. It is a whole number. And it is a natural number. The most specific would be natural.
Are you just going to ask for the most specific on the test?
No, it's going to have all of them listed. And it's multiple choice. Did I mention it? The test is multiple choice. This is just free response. 7 would be a real number. It is a rational number. It goes all the way down to whole number. So it is an integer and a whole number. And then it's not a natural number because it's 0. And 8, we got pi. So it's in the chart, so it's a real number, but it's none of this stuff. It's irrational. And next.
So,
Yes.
when would a number not be real?
It's like the imaginary numbers and stuff that you'll see in calculus.
So, the answer is going to be real like 90%.
Yes, for now. Okay, next.
It's like
Infinity and imaginary numbers, that's all. Okay, name the property illustrated by each equation. So remember the properties that we were working with was commutative, where they changed the order. There was associative.
Will we have a word bank for this part, or is it just...
It's multiple choice.
Okay.
Yeah. Distributive. And identity were the main ones. Whoa, I didn't realize you couldn't see that. Those are the ones I wrote down. Commutative, identity, associative, and distributive. So looking at that first one, number 9, it has those parentheses, which I kind of think of associative every time I see those parentheses, but it's just to trip you up. Look at the order of the numbers. We have 5x, 4y, 3x, and then 5x, 3x, 4y. They changed the order of the numbers here in these parentheses, so that would be commutative. And then there'll be 2 answer choices for commutative property of addition and commutative property of multiplication. And since it's changing the order of addition, it would be of addition. The next one, I see the parentheses again. I'm thinking associative. I just make sure the numbers are in order. 7x plus 9x plus 8, 7x plus 9x plus 8. They're just changing the grouping. So that is associative. And since it's addition, it's addition. The next one, cross it out. For whatever reason, the answer key says it's reflexive, which I would just say that's identity because we learned that 1 times y equals y. I'm just going to take it off. Next, find the additive inverse and multiplicative inverse for each number. This is both easy and hard depending on how you look at it. But we're going to find the additive inverse and the multiplicative inverse for both of them. So just write add and mult. And when you're finding the additive inverse, you want something that adds to it that equals 0. And then for multiplicative, you're looking for something that you multiply by it to equal 1. Yes?
For additive, don't you just add or like switch the sign?
Yes, pretty much. Yeah, the additive one is really simple. Whatever number you have, just put the positive or negative of that. So negative 11 over 16, the additive would just be positive 11/16. We can go through and do all the additive ones. This would be negative 0.4. This would be positive 1.6. And then for 5 and 5/6 would be negative 5 and 5/6. That part's easy. Then for multiplicative, you're looking at for something you can multiply by to get 1. What you can multiply by is the reciprocal, or in this case, negative reciprocal. So it would be negative 16 over 11. And if you multiply this out, you'd get 1. So negative 16 over 11. If it's represented in a fraction, this part's easy. Then for the next one, we're given a decimal. In order to do this, where we just like flip the fraction, we need to have this as a fraction. So 4/10 as a fraction would be 4/10. Simplified, it would be 2/5. Then you can multiply by 5/2 to get 1. So our multiplicative inverse is 5/2. I'm going to use a sticky note for a little bit more space to show how to do 14. We have a decimal. We need to get this into a fraction. So negative 1 and 6/10 fraction. Simplified, it would be negative 1 and 3/5. We have to make it an improper fraction. Is that what you're saying?
Yeah.
Yes, or
Can't you just do a negative 1 over 1.6?
no. I guess if you did it in the calculator, it would give the right answer. Let's see, 1 divided by 1.6. Oh, I just did 1 divided by 1.6. It works. Okay, but the proper way to do it is 5 times 1 is 5 plus 3 is 8 over, I'll show you Harut's way in a second. 8 over 5, so negative 8/5 is what negative 1.6 is, and then you flip that, negative 5/8. So this would be a negative 5/8, and as a decimal, that would be negative 0.625. So in the calculator, you could do 5 divided by 8 and get negative 0.625. Harut's way was, okay, if you just flip the fraction, 1 over 1.6 would give you the answer. Technically, you would never write a fraction like that, but it does work. 1 divided by 1.6, 1 divided by 1.6 gives you 0.625. So it does work if you do it like that. So
Would you want us to write just 0.65?
it'll be multiple choice, and it just so happens for this problem the multiple choice answer is it's in a decimal.
Oh.
Yep. Harut's so proud. Okay. It's okay. Any more hacks, let us know.
It's like, I don't like this way, so
It does work. It works. Okay. 15. I feel like we just should skip to roots. Wait, let's see. 5 and 5/6. Put it as an improper fraction. Be 35 over 6. And then flip it, you get 6 over 35. And for whatever reason, the answer choices here are in a fraction and not a decimal.
The other one earlier was a fraction.
I know. I don't know. Oh, but that's because the decimal looks like this. Yikes. So this one, the answer choices are in fractions.
It's 6 over 35, right?
Yes.
So why was the first one negative? Because the starting thing was negative?
This here, yeah, because you needed a positive one.
Got it.
Okay. Next, simplify the expression. How are we doing on time? 24. Okay, we're good. Simplify each expression. Make sure you have your variables in alphabetical order. Also, you'll likely have to distribute. So here is a negative. We're going to distribute to both of those terms. 8x minus 7y minus 3 plus 6y. Now I'm going to combine like terms. There's only one term that has x, so 8x. Negative 7y plus 6y would just be negative y minus 3. And we're done. Katie, do you have to go to that? Just ask next time. You're good. You're good. As long as you're okay with missing this. What's that?
The minus 3.
Oh, negative times 3 was negative 3.
Oh.
Okay, next, distribute 3r minus 30t. Distribute here. Negative 28t minus 8r. Alphabetical order, so put the r's together first. Negative 5r. Negative 30 plus negative 28 would be negative 58t. And we're done. Next, write an algebraic expression to represent each verbal expression 5 times, so I'm thinking 5 times the sum of a number and 1, so x plus 1. So writing this out, 5 times that would look like this. (19) 1 less than, so we're going to be subtracting 1 from whatever we do. Twice the square of a number. Twice the square of a number. Minus 1. And now it says write a verbal sentence to represent each equation. That equation is back up at the top. So moving on. 20, we're going to write a verbal expression for this. It'll be multiple choice, so you're choosing the verbal expression from multiple choice. But here's how we'd write it out. Here we have m divided by 5, so we're looking for the quotient of m and 5. I'm writing it up here because I'm not going to have enough room here. So the quotient of m and 5 equals or is 3 times the sum of twice a number and 1. And that would be here. I remember all this stuff being on the SATs. Like the properties, I remember this kind of stuff. Solve each equation, check your solution. So here I'm going to use a sticky note so I have enough room. Solving should be pretty easy for most of you. We're just trying to get r by itself and see what it equals. So we're going to subtract 5 from both sides. this divides out to 8. So r equals 8.
Hold on. I just screwed up.
Next. Good? See my
I'm a little behind.
Okay.
Sorry. Almost done. Alright, you're good.
Next. Okay. Next one. Same idea. This time we do have to distribute the 5 to both of those terms. So we get 30 minus 20, v equals v plus 21. If you're working ahead of me and got a fraction, that is correct. I'm trying to get v over by itself, so I'm going to subtract 30. I get negative 21v equals negative 9. Then divide by negative 21 on both sides to get v by itself. We have v equals negative 9 over negative 21. Not very pretty. This is not in the answer choices. They have it simplified. So divide by a common factor, which would be 3. We have v equals negative 3 over negative 7. This is not in the answer choices either because negative divided by negative is just positive, so it's 3/7. Okay, next, got it?
Yeah.
Okay. Now we're going to evaluate absolute value expressions. We're just plugging in the numbers and then solving using that absolute value symbol. So here we would get, actually I can squeeze it in here. 2 times negative 8 plus 4 gets negative 16 plus 4, which would be absolute value of negative 12, which would be positive 12. So whatever's in the absolute value symbols will turn positive. If it's already positive, it stays positive. Next one, same idea. 1 minus 7 times 5. The a is negative 1. There's like a negative up there. Then once I have it all written out, solve with what's in the absolute value first. Then minus, this would be just positive 1. And this would be positive 34. So 34 minus 1 is 33. Because that subtraction symbol is outside of the absolute values, it stays. Next. Oh. Okay. You hanging with me? I'm trying to finish before class is over. Okay, now we're doing the absolute value equation, solving these. Remember, you'll have to actually solve these twice, so that's why I got out the sticky note. If you want to do this on the back of your paper or your scratch sheet of paper, that's cool. It says to check your solutions, but honestly, if all the answer choices have 2 solutions, you don't really have to check because the 2 you get will be the correct answers. Yes?
Wouldn't you add a 1 because the negative and the negative 1 become positive?
So this negative 1 becomes positive. But since this is not inside the absolute value symbols, it just comes back as, it's just,
Why does that become a positive?
because the negative 1 was inside the absolute value, so that turns positive.
Still comes as 33.
What's that?
It still comes as 33 if you change it to positive.
Oh, yeah, if you like add the opposite, yeah. But just do it the right way. So this becomes positive, and then this just stays subtraction because it's outside of that absolute value. Okay. Next one, these expressions you have to solve twice. In this case, it already has absolute value by itself. So we're going to do 2y minus 3 equals positive 29, and then 2y minus 3 equals negative 29. And then from here, you just solve. It's come out to a fraction. Okay, so I get 16 and negative 13. The order, ooh, my brackets are struggling. The order of these numbers doesn't matter, so if all the answer choices have it with the 13 first, that is fine. Both of these would be correct. Negative 13 and 16 are both solutions, or 16 and negative 13 are solutions. In this case, all the answer choices would have two numbers, so you don't need to go back and check because you know there's going to be two solutions. Yes?
In the absolute value where it's 2y minus 3, do you change that minus to a plus?
Nope.
Or is it only when it's in front of the...
So you'd solve whatever's in that absolute value first before you changed anything. So let's say y was 3. You would still do like 6 minus 3 is 3. And then if that was negative, you turn it positive.
So on the test, how will we know to do how will we know not to just solve for y?
Because of those absolute values.
The absolute values is
Yep.
what is like, hey, solve both.
Yep.
Other than that, okay.
And you'll know because the answer choices will have two.
Okay.
Like they'll have the brackets and stuff, so. Okay, 26, same idea. The only thing is that the absolute value is not completely by itself yet. So we're going to get it by itself by dividing both sides by 7. Then we get absolute value x plus 3 equals 42. Oh wait, not 42, 6. Start over. So absolute value x plus 3 equals 6. From here, now that you have absolute value all by itself, we're going to set this equal to positive 6 and negative 6. Then we get 3 and negative 9. For this one, I know for a fact that all the answer choices have two solutions, so you don't need to go back and check. The next one, we're going to go back and check. Oh, I didn't realize that you couldn't see the whole thing. There you go. Ready? I got lots of eyes staring at me. You got it all down? Next. 27. Okay, for this one, again, we need to get